everyone, welcome back. We're still in Module 2. We are in Topic 3. We are in Lesson 3. And we are doing the introduction and then the getting started. Seeing things differently. Multiple representations of unit rates. Our learning goals. Represent and identify unit rates using tables and graphs. Recognize that the ordered pairs x, 1 and y, 1, y are both points on the graph of a unit rate because it would be a per one. Graph unit rates in the real world situations involving unit pricing and constant speed. Compare unit rates based on their graphs. Okay, so determine whether each graph represents equivalent ratios. So we could number these 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In order for these ratios to be equivalent, when you're looking at a graph, two things have to happen. One has to go through the origin, and two, form a straight line. Okay, let's connect these and see if that happens. Then I want to show you something else. I don't know where I did the paper that I was using as my straight edge, so I'm just going to use this. Okay, so let's see if that line goes through the origin. And connects all the dots, and it does. So this should be, yes, it should be equivalent ratios. So let's look at these ordered pairs though. So we have the ordered pair 2, 3. So we have 2, 3, and then we have the ordered pair 4, 6. And let's see, 5. That one doesn't go right through. That's kind of like in the middle. So let's use this one, 6 and 9. Okay, so if we set these up as ratios, if we said for every 2 you go over, you go 3 up, is that equivalent to 4 over 6 up? Are they equivalent ratios? So a times 2 times 2, that is. What about with 6 and 9? So 2 times 3, 3 times 3. So they are. So these are, yes, equivalent ratios. Okay, so what about this one? It's 2, 3, 4, 5, 6, 7, 8. They are so small. 1, 2, 3, 4, 5, 6, 7. Okay. Fill those in there. Okay. So if we looked at it in this way first, maybe this time, this would be ordered pair 2, 3. The next one that crosses exactly is 6, 5. Do we have a consistent increase here? Well, 2 times 3 gets me to 6, but 3 times 3 is 9. So that one doesn't seem to work. What about the 8, 6? So 2, 3, and 8, 6. That would be a times 4. So this one I'm going to think is a no, based on trying to set up equivalent fractions or ratios that are in fractional form. But then let's see if we connect these dots. can probably do better than that. But it's not going to go through the origin. And because it does not go through the origin, we can immediately say no on that one. Does not go through the origin. I'm sorry, I may have had this off the screen. Let me move that over. I'm just going to pause here for a minute. You can pause the screen if you need to go through and write. I apologize if that was over. I don't have another copy of this, so I don't really want to redo this at the moment. Okay, so 2, 3 over 2 up 3 and over 6 up 5, they are not equivalent. In fact, we know that right away because this numerator is less than this denominator, and this is the other way around. Same with here. So these are not equivalent ratios. Okay, moving on. Next page. The need for speed. In a car, a speedometer shows the driver the rate at which the car is moving, which is its speed. Many speedometers are like double number lines arranged in a circular shape. The numbers on the outside of the speedometer show the rate in miles per hour, and the numbers on the inside show the rate in kilometers per hour. Use the speedometer to estimate each rate. At about what rate in kilometers per hour is the car moving if it's traveling 60 miles per hour? So here's the 60 miles per hour, and down here's the kilometers. So here's 80 kilometers, here's 120. So this line right here is 100 kilometers per hour. It's halfway between the 80 and the 120. So this is going to be somewhere between 90 would be about here. So somewhere between 90 and 95 kilometers per hour. And that's a cursive K, kilometers per hour. At about what rate in miles per hour is the car moving if it's traveling at 60 kilometers per hour? Okay, so 60 kilometers, remember that's the smaller one, so that's going to be right here between the 40 and the 80. So that's going to match up with 40 miles per hour. About how long would it take to drive 90 kilometers at 55 miles per hour? Well, we already talked about that 90 being right here around the 60. So if 90 kilometers is about 60 miles per hour, and that's how far we've driven, is 60 miles. So in the 55 minutes per hour, it will take about 1 hour. Since 90 kilometers is a little more than 60 miles, so driving at 55 miles per hour means that it'll take a little more than an hour to drive the 90 kilometers.